Knowing that the chemistry of lanthanides, Ln, is dominated by its +3 oxidation state, which of the following statements is incorrect? Right? Now, do you know what are lanthanides? Lanthanides are the 14 elements after lanthanum. Right? That is, it starts from your cerium 58 to lutetium. Now students, these are the lanthanum, and you must be knowing that these are F block elements, and the general electronic configuration goes as how? It is N-2 S and so N-1 D, right, and NF. Or I can write the configuration as 4S, 5D and 6F. Right? So, in these, where are the electrons present? They are present in your F orbitals. Right? Now, let's take up the options. Because of the large size of lanthanide 3 ions, the bonding in its compounds is predominantly ionic in character. Of course, they do have large size. Say, if I am taking cerium 3+, it is a large size and an cation. Now, do you remember Fajan rule? What it states? It suggests that larger is the size of the cation, less is its polarizing power. What is polarizing power? It is the force of attraction of the nucleus for the electrons of the anion. Right? So, if large is the size of cation, less will be the attraction of its nucleus towards the electrons of the anion, and the bond will be predominantly of ionic in nature. So, our first option is correct. Now, the next is the ionic size of Ln3 ions decrease in general with the increase in atomic number. Is it the thing, students? With the increase in atomic number, what happens? Increasing atomic number. What happens? The size should increase, right? But here what is happening, students? In this case, the electrons are added to the same shell, right? The size of the lanthanides decrease. Why it decreases? Because the effective nuclear charge. What is effective nuclear charge? It is the net force of attraction of nucleus on the valence electron. The effective nuclear charge increases right? Because of the there is greater effect of the effective nuclear charge, right? And this increases because of the less of the screening effect. Or you can say that cerium to lutetium, they are arranged from left to right in the period and the size decreases. Now students, here what is happening? Every time, I would like to elaborate this point, here what happens? Every time an electron is added, what happens? The size is decreasing. Why? First of all, the effective nuclear charge is increasing, that is the net effect of attractive force of nucleus on the valence electron. And secondly, there is one more reason, that your D and F orbitals, they are very big in size. So there is poor screening or shielding effect. Right? Now if I draw the diagram like this, see this is this big, right? And we have got the nucleus at the center. Now students, the orbitals which are present within are what? They are the big orbitals, like your D and also the F. So these big orbitals have got poor shielding effect, and due to this poor shielding effect, what happens? The effective nuclear charge increases. Right? And due to this, what happens? Your size of the ion decreases. So this is also the correct option. Now we have got the next option, that is lanthanide compounds are generally colorless. Will they be colorless, students? Where is your last electron coming? Our final electron is coming in the F orbital. Right? Will all the lanthanide have 14 electrons? No. Cerium will have 3d, 5d1, 4f1, sorry 6f1. Likewise, your lutetium will have f2. Likewise, the electrons, they are moving in what? F orbital. So what happens? Due to the FF transition of electrons, FF transition of electrons, what happens? The compound shows color. Like your transition elements. Transition elements show color because of the DD transition of electrons. So this statement is incorrect. Now let's take up the next also. What is our answer now? The answer to this question is C. Now lanthanide 3 hydroxides are mainly basic in nature. Will they be basic? LNOH thrice. Yeah, they'll of course be basic. Why? Because they are metal hydroxides. Okay, and secondly, they have got ionic character. They lose their hydroxyl ions easily. But what will happen from cerium to lutetium to the basic nature of hydroxides? It will decrease. Basic nature of hydroxides will decrease. Right? Why? Because the size is decreasing, and as the size is decreasing, the bond strength between the lanthanide and the hydroxyl will be more, and it cannot lose hydroxyl ions easily in the solution. Right? So this option is also correct. So what was our questions? Most of the time students, they get confused, or they don't put more stress on this thing, this word. It is correct or incorrect. See students, there is a difference of IN only, but for you it's a difference of 5 marks. Do read the question carefully, whether you have been asked to mark the correct answers or the incorrect answers. Do take this thing seriously, right? So our answer is the lanthanide compounds are colored because of the presence of electrons in the f orbital, and there is F transition of electrons.